Hello everyone, welcome to the series of videos. The first part of the series of videos, IT for biomedical students and biomedical engineers. So before we begin, I would like to give you the quick introduction. The purpose of this training is basically purely knowledge sharing. So ilm sharing is what the purpose of this training is all about. So who this training is for? This training is for the biomedical students and biomedical engineers who wants to involve them in the IT as well. When I say IT, the medical IT, because these days all the medical equipments are coming with always with the network ports and the network features and the softwares and so on. So this has become basic skills everybody needed these days as a biomedical students or engineers. So every day-to-day life you deal with the medical equipments. You are an experts medical in the medical equipment side, but you will also want to learn about the IT behind every medical devices. So that is one of the reasons this series is made for, and this comes and covers all the basics of the networking and so and so. But who this training is not for, because you for biomedical, yes, it is needed, but if you are an IT engineer or you are already working in the field of healthcare IT, meaning like you are involved with implementations of the healthcare IT solutions, this training is not for you, because you may not get any new informations in this series. So I would like to save all of the time for everybody. Thank you. Let's get started. So before we begin, how this course is structured, I structured this course with the networks and then the basics of networks, the components of the networks, and goes on and on. Network is very important to understand, because in the medical in IT world, what happens is everything which is for example, databases, servers, so handling so many jobs on the IT side, everything begins with network. So we should cover the basics of the network so that we are good with it. So what is a network? Network is connecting the group of devices together so they can share the data among each other. For example, let's take our situations. You have, let's say this is an ICU. Here you have patient monitors in every rooms, and then you have a printer and the central monitoring station at the nurse station. So let's say that this is a nurse station and this is a ICU bed 1 and 2, 3, so on. So in order for these to communicate with each other, you need to form a network. You need to connect them through a line. So that line helps to share the data from the patient monitor and all the way to the central station, and the same thing from back and forth, because the waveforms are coming from the monitor to the central station and it goes back and forth with devices, instructions and so on. So the same thing happens with the other devices. This is what it is. So how this networks can be formed? Either it can be formed through the cables, Ethernet cable, or it can be formed through the wireless. If a device supports wireless, it's gonna go to the wireless. If device supports Ethernet connections, it goes to the network connections. But if you ask me which is the preferable, Ethernets are the always preferable. We will see why it is in the future when we understand the differences between the physical network and wireless network. So there are two different types of network, LAN and WAN, and there are many, but what we normally hear is LAN and WAN are the most popular networks. We look at them in details. So let's say what is a local area network. So the local area network is like connecting the devices through a common medium. Let's say this is the network switch. Okay, so you have too many devices, 1, 2, 3, 4. So you connect them all together using a common medium, and that is how you just forming a network. So you can talk to each other. All of you can talk to each other. When I say all, meaning someone who's sitting here, or the application or software sitting here can send the data to the other devices, and this can happen vice versa. So this is what happens. So what is the difference between the LAN and WAN? The primary difference is this LAN is located just inside your hospital. This is what you have to think. So let me quickly erase that. So this particular thing is just located in your hospital. It's not outside of your hospital. So you just take your hospital and you form everything using your devices and your cables and your network devices here. So everything is internal and it's in a small geographic area, it's in your eyesight. So that's how you form local area network. One of the examples I can give you is your home network. In your home you have a Wi-Fi access point and everybody is connected to it, right? Or a small switch. Like for example, you have your PC, you have your laptop, and you have your phone, you have so and so. So by this you are forming your local area network. This is called LAN. One thing is you have a LAN and there is in a home too, right? There is your neighbor. He will have his own devices and he's in his own network. So that is his own LAN. So he has his own LAN, you have your own LAN. So this is local area network, this is local area network. Something like this in your hospitals, be whatever you have inside your hospital, that's your local area network. So what is then wide area network? Let's say that you have different hospitals. So you have hospital one which is located in India, and you have an hospital two which is located in Malaysia. It's the same group of hospital. Let's say the hospital name is ILM. So this is ILM 1 hospital, ILM 2 hospital, this is ILM 3 hospital. It's located in Singapore. So in this case what happens is they will have their own LAN. Here they will have their own LAN. Here they will have their own LAN. They all talk to each other. These devices talk to each other. This talk to each other. So they do this. Something like this as well happens. Like they will talk to each other. Same here. But what happens is the device here from hospital 1 talks to device 2 or device 3. So that's when they do something like, let's all interconnect all these 3 networks as one network. So they connect all of them as a one network through internet. So they connect them through internet using some kind of routers and routing in between, which is internal to them as well. So that for outside it won't be a big deal, but for everybody who is inside the hospital, it will look like all the hospitals are interconnected. So you're connecting 2, 3 or more LAN together through internet. That's called wide area network. But in the biomedical world, you will not be more involved with wide area network. Your focus will be mostly on the LAN side. So the biomedical focuses should be on the LAN side. So your focus will always be LAN side. What are the devices comes in the LAN, how you configure them, what are the requirements and all this thing. You always focus on the LAN part. Internet part is really not a scope of a biomedical engineers. That pure core IT team will take care of it. So we have a lot of building blocks of the network. How do you form a network? Very simple. You take a PC or your medical devices per se. So your medical devices, let's say that you have a patient monitor or something like this, and then you have NIC cards. Every devices comes with a network interface card, and then you take an Ethernet cable, you connect the Ethernet cable, and that's connected to the network switch, and that's how you're connecting these devices to the network. And then you take another device too, and you connect to the next port. This is like a 24 port switch, and you take another devices, you connect device 3, device 4, something like that. So this simple here, what you see here, that is a symbol for network switch. Every time you see this, it means network switch. In networking world, we use this symbol to represent it. This is a switch. In something like this, some people write like this as well. So this is also called switch when you draw something like this, right? So you connect this and you form the network. You have D4, D4, and device 1, device 2, all these are connected, and all they can talk to each other through this device, through this network device. So what they can do if they want to go out of this network, because this is a one network, right? Because this is like a one network. But what if they want to go to the other network? That's when the network switch comes into play. Right? So that's when the network switch comes into play. So this devices will take all the data from the switch, and then it will send to the internet. As I said, this is the logo or icon for the router. So we will sometimes write like this. So this is called router as well. So the function of the router and switches we will see in detail in the next slides. So then it comes out of it. So from the devices, it goes to the network switch. If it is a local area network, it will only use the switch. It won't come out of it. If it has to go to the wide area network, or it has to go to the different local area network or something else, it will go through the network router, and then it will go out. If it needs to go to the internet, and then from the router it will reach the internet, and then it will go to the google.com or whatever. All right. So these are the components you just need to form the network. It's a very simple basic, but still I would like to highlight it. So just quick introductions about the components we have. We have Ethernet cables of two types. One is straight through cable, other one is a crossover cable. Most of the times we use the straight through cable these days. Crossover cables are used on special cases. The difference is the pairing of the cables. For example, this particular part has an 8 pin, and then the other end will have the 8 pin. So if you see this, so 1 2 3 4 5 6 7 8, and this will have the other side. This is one side. I meant to say this one is like this. 1 2 3 4 5 6 7 8. So if it is straightly connected, it's called straight through cable from 1 to 1, 2 to 2, until 8 to 8. This is straight through. In case of crossover, what happens is some cables will go to the other port, not 2 to 3 or 3 to 2, and there is a standard which defines how the crossover cabling pin should be. But why do you need a crossover? Sometimes you may need a crossover if your device manufacturer advise you to use a crossover to connect their medical devices to your PC, just if you want to do a configurations. Yeah, something happens. But usually we use a straight through cable just to connect our devices to the devices like this. This is mostly straight through cable. Okay, so here you have another devices as NIC card. On the NIC card part, you have each NIC card has an address called MAC addresses. This is 48 bits. So 8 bits is one of 8 bits comprised is 1 digit. So 888, or totally it will be 48. Out of this you have 12 digit address. So out of this, you see first half, this defines who is the manufacturer, and this defines, this particular second half defines this portion, defines unique ID. So every devices will be identified using the differences. For example, one devices will have AB, other devices will have AC, AD, or instead of 9 it may be 0 AC, 0 AB, something like that, so that you will have different combinations. So each devices will have its own ID. Through that, the network switch can find how to send the data to the other people. Okay, so because network switches mostly relying on the MAC addresses to forward the data from one devices to the other devices. So it will look at the MAC addresses for the where to send the data, and then it will send that data to that devices. Okay, another one is switches do the broadcast. What is broadcast? We will see in detail in the other videos, not in this, but quick introduction. Broadcast meaning whenever the sometimes if D1 wants to send the data, it's like I want to send the data to everybody. When that is the case, the data comes to this particular port and then it will go out of all the ports. It will be broadcasted, right? So that is called a broadcasting. But some case switches wants to do only one to one. For example, D1 say I want to send only to D1. In that case, it will go to the switch and it will directly go to the D2. It won't go to all the places. Okay, so that's called unicast kind of traffic, and another one is the broadcast. It depends upon the source how they want to send the data to. Switches have the capability to do the broadcasting. So there are two types of switches we can see. One are the managed switches, another one is the unmanaged switches. So the unmanaged switches is something you can see at your home or anywhere. You can just buy it in the shop for very low prices. It's very easy, but you don't do much things in it. So what you just can buy it from the shop and you just connect the one device here, and you connect the device 2 here, and you connect the device 3 here. That's it. All can communicate with each other, no problem. It will just work just when you open from the box. But this switch is not like that. It has a lot of capabilities compared to this. You can do so much of configurations. Usually the medical equipment vendors will ask you, your network should be like this, your network should behave like this, that. But when they say that, you can't do much in this. Only here you can do. So you can configure the way how the speed, how the communication should be two-way or one-way or both at the same time. There are so many things out there which can be done here, which we will look at the different videos. But these are the switches you can use, you normally use in the hospitals, but these are the switches people do use at the lab, or sometimes when they don't have much things, just they have 2-3 monitors, or like or just they're in a small ward or something like that, they may use the switches. It based upon your needs, but managed switches involves a lot of IT works in it. Unmanaged switches needs nothing. You just buy it and you pull it and it works fine, but you can't do much in that. So the router, so it's a very important concept, router. So let's take this network structure. You have a local area network here. This is one LAN, okay, and this is another LAN. Let's say this is LAN 2 and this is LAN 1. So you have devices like A, B, C, and this is D, E, F. Okay, so what happens is if A wants to send the data to C, so the A will send the data in packets. Let's say A, it will send data as a packets, and that this packet will have two addresses, two MAC addresses. One is source MAC, other one is the destination MAC. So as I said, the MAC address is something which is hard coded into the NIC cards, right? So the NIC card of A, NIC card of C, the address. So when it does that, the data comes out of this, and then this particular packet, right? Every packet comes to the switch. So what switch will do? Switch will look at the source address and the destination MAC addresses, and there is a process before that how the A knows the MAC address of the C, right? That is a different process. So that we will look at later. We will not go in detail of that, but for now it keep this in mind. The packet has a source address and the destination MAC address. So the switches will look at both the addresses, then it will see, okay, destination MAC addresses. So this destination MAC addresses is the MAC address of C. So this switch will have a table. So in the table it will have A and then the MAC address of A, B MAC addresses of B, C MAC address of C. Also it will have one more column where this is connected here. For example, this is port 1, port 2, port 3, port 4. So it knows, okay, I have C connected through the port C. I mean, this particular MAC address is what you are giving it to me here. This belongs to C. And on my switch, this C is connected to the port 3. So I'm going to send the data through that port 3. So it's going to send the data through the port C. So the communication is over. It's well and good. The same thing happens if D wants to send something to the F. It sends the packet to the L and then it comes out of the E. If it wants to send to E, it goes to the E, right? It's from D to E, something like that. But it does not cross the other network. So this is a single network. But if A wants to send data to D, what happens? Right? In that cases, A doesn't know the MAC addresses of D because they are not in the same network, because they are in a different LAN. So somehow it will send the data to L, the switch here. Let's say this is switch 1, okay, and this is switch 2, SW. So what happens? This goes to the SW1. What SW1 will do, it will look at its table. For sure it doesn't have any match for that because it's in a different network as well, because before it looks at the table, it will look at the IP and it will understand that this IP does not belong to LAN 1, it goes to the LAN 2, so it won't do much. So what it will do, it will send it to the router because this is a different network. It will find it using the IP address, it's a different network. We will look at it, the difference between the IP addresses and the MAC addresses in a different video, but just keep in that mind. Switch 1 will find out, okay, you want to send packet to D, but I don't have D connected to my switch, so I'm going to send it to the router because D is not directly connected to me. So it goes to the router. What router will do? Router will send to the switch 2. So what then the switch 2 will do? It will have its table because it understands, okay, D belongs to me, and then it understands that, okay, D, where it goes, okay, 1 2 3 4 port, okay, sorry, this is 1, this is 2, this is 3, never mind this, okay, 1 2 3. So it knows that, okay, it should go to the 1, so then it goes to here. So let me try to change the color so that we will, let's put green. So if A data comes all the way to L2, L2 sees, okay, I don't have this connected directly to me, so I'm going to send it to the router. Then the router will send it to the L2. So how router know? It knows. Then I will tell you how it knows. And then it will check its table. Yes, D is connected to me, I know D, so then I'm going to send it to D. So this is how it's going to work. So this is what router functionality is. If you see this, router functionality is connect to different networks. Switches create the network. For example, if you connect a switch, you're creating your own network. If you connect a switch, you are connecting your LAN 2. So switches create a network. A router helps to connect the network, see? And then a router is connected at least to two different networks. Meaning, router functionality is to, so the router functionality here is to connect the two different networks, but it can also have more networks, like for example here one LAN 3, here LAN 4, but minimum it should have two networks, otherwise the function of router is not useful. Okay, and I told you, right, it can find where to send. For example, when the packet from A comes, it should know I should send to switch 2, not to this direction. How it will know? It has a protocols running inside in the router. That router will find it how to take the data, so that will have a direction. Okay, I should send it here. Okay, this is what it is, and you should know this. Router never do broadcast. What does broadcast mean? Let's just try to erase few things. Alright. So what is router never broadcast? I said right, switches have the capability to do the broadcasting. So let's say that A said, I want to send this particular packet to everybody. Let's say this packet is packet data. Okay, it says it is a broadcast. I want to send it to anybody, everybody. So what happens? This comes to the switch. Switch will send this one copy here, one copy here, and one copy here. It won't send back to the same port, but it will send it to every other port. What router will do? Router will open the packet, and then it will see, oh, it's a broadcast packet. I'm not going to do anything, and then it will just drop it. So the broadcast packet will not move out of this network. Same thing here. Let's say that here E wants to say, I want to send this packet to everybody. So what happens? The packet comes to L2 switch here, switch 2, and then it goes to here, and it goes here, and it goes here. But when it comes here, router will see the, oh, this is a broadcast. I do not need it, so it will drop it. So that's what it's going to happen. So we'll take a brief, a deeper look at what is broadcast, what is unicast, and so in a next video or other videos. So that's it from my side. Hope this video is useful, and this is the first of its kind, first of this video I'm doing. So I hope it is useful. Thank you for your time. These are the takeaways. We did see what is network, what is local area network, wide area networks, components of the network, basics, things of switches and routers. If you have any queries, please do send an email to me. I can respond back to you. And see you in the next video. Thank you for your time.